This is question number 14 from the 2016 practice exam. And we have a function f, which consists of our three line segments. And we're also told that function g is an antiderivative of f. And we have some information about g. We're told g of 2 is equal to 5. Now we want to find how many values of c in our interval from 0 to 6 is g going to equal 3. All right, well, this is an application of the first fundamental theorem of calculus. So the first fundamental theorem of calculus tells me if I take the integral from a to b of f of x dx, I am going to get the antiderivative of f, which in this case is g, evaluated at b, minus g of a. So we're going to use that a number of times here, in fact 3 times. Right? Now I'm going to break my graph up into 3 sections so that I can utilize this piece of information right here where g of 2 is equal to 5. So I'm going to actually start my integral by going from 0 to 2. Okay, so I'm going to go 0 to 2 of f of x dx. So that is going to give me g of 2 minus g of 0. Now this is a little trick that's done a number of times in AP exams. All right, well, this first part here is just the area under my curve. So that is this area right in here. All right, now if I look at that area, I have a base of 2, a height of 2, that's 4 divided by 2. That's going to be 2. Now, g of 2, we're told in our question, g of 2 is 5. So that is 5. And we're going to use this then to find g of 0. So, little rearranging, what minus 5 minus something is going to equal 2? Well, g of 0 is equal to 3. Okay, let's move that out of the way here. And let's do that one more time. All right, now I'm going to look at the next piece, and I'm going to take the integral from 2 to 5 of f of x dx. Well, that is going to give me g of 5 minus g of 2. So once again, this part here is just the area now here. This we know from our question, and we'll figure out what g of 5 is going to be. So my area, base times height divided by 2, so I have 3 times 2, that is 6. I'm going to divide it by 2 and get 3. It's below the axis, so I'm going to make that negative 3. And we know that g of 2 is 5, and we're going to solve for g of 5. So a little rearranging. If I take this to the other side, I now get g of 5 is 2. All right, let's try this one more time. Let's move this up out of there. I'll just make it a little smaller. Set that over there. All right, now we're going to do this one more time with our third interval from 5 to 6 of f of x dx. Well, this is going to give me g of 6 minus g of 5. Okay, so this is my area again. Now, I don't have g of 2, but I did just find g of 5. So I know what that one is. All right, so my area, base times height, is going to give me all of this area in here. That's 1 times 4 divided by 2. That is 2. There is g of 6. And we just said that was 2. So again, we want now what minus 2 is going to equal 2. A little switch and bring that over. G of 6 is 4. Okay, let's move that. Okay, so we've found three pieces of information. We have g of 0, we have g of 5, we have g of 6. We're told in the question what g of 2 is. So I'm going to make a little coordinate plane here going from 0 to 6. And I'm going to mark off a couple of things. There's 1, there's 2, 4. Oops, that'll be a little bigger, but that's 6. Okay, so there's 2, 4, 6. All right, we know that g of 0 is 3. G of 2 is 5. So that's going to be up here. G of 4, we don't know. What do we know? G of 5 is 2. And g of 6 is 4. So we got g doing something like this. Well, we want to know how many times does g equal 3? Well, it starts out at 3, and we get 2 more times. So there are 3 times where g of c is equal to 3. That was a long one.